So in this video we're going to finish up section 7.2, verifying trigonometric identities. In example 4, in the last video we talked some of the guidelines about simplifying these, and one of the guidelines to try was maybe convert everything to sines and cosines if you can. So that's our clue here for example 4. Verify the identity that tan x plus cotan x is equal to secant times cosecant. So the clue was, again, convert sines to cosines. Tangent we can replace with sine divided by cosine. Plus, cotan is the reciprocal of tan, so we just flip this upside down. Cos x over sine x. Now if we notice back to the original problem, on the left-hand side we have two terms, a tangent plus a cotangent. On the right we have two things that are multiplied. It's a single term. So to go from two terms to one term, or one term back to two, we're definitely going to have to use a Pythagorean identity. You know, that would be like sine squared plus cosine squared equals 1. We can subtract, let's just do cosine from this one. Sine squared equals 1 minus cosine squared. So we can go from a single term to a two term by using a Pythagorean identity. So we need a common denominator if we're going to add two fractions. Well, our denominator is just going to be these two multiplied together. Sine x times cos x. Our denominator on the left already had cosine, so we multiplied by sine. We must also multiply the numerator by the same thing, sine. Sine times sine is sine squared. Or, you know, you could think about it as sort of multiplying up on the diagonal. Sine times sine, sine squared. Plus, over on the right we already had sine, so we multiplied by cos. We got to multiply the numerator by the same cosine, or again, think about it as cross multiplication. Cos times cos is cos squared of x. Now here's where that Pythagorean identity helps to go from two terms to a single term. Sine squared plus cosine squared is 1. 1 over sine x times cos x. And now we have two things multiplied, we can pull them apart. So our first fraction would be 1 over sine of x, and then times 1 over the cos of x. You know, I just took what we had up here and pulled it apart. Now we think back to our reciprocal identities. 1 over sine is cosecant, times 1 over cosine is secant. Cosecant times secant is the same thing as secant times cosecant. We have our multiplication properties. It doesn't matter which one we put first because we're just multiplying them anyway. And again, those to go from two terms to one term or the other direction, you've got to use a Pythagorean identity. Recall from algebra that rationalizing, that was supposed to be my highlighter. Rationalizing the denominator using a conjugate is on occasion a powerful simplification technique. A related form of this technique shown below works for simplifying trig expressions as well. So we have this 1 over 1 minus cos x. So we're going to take our 1 over 1 minus cos x and multiply by the conjugate of the denominator. And let's look at that denominator. It's 1 minus cos x. So our conjugate is going to be the same terms, 1 and cos x, but we change the sign from negative to positive. So when we multiply straight across, 1 times the numerator, 1 plus cos x, is 1 plus cos x. And the reason we choose the conjugate is now we can FOIL it out and we will have no middle terms. Or if you remember the algebraic shortcut of a sum and a difference, you know it's 1 times 1 is 1. It's always a minus, and then cosine times cosine is cosine squared. 1 minus cosine squared. And that 1 minus cosine squared we can replace with a sine squared, Pythagorean identity. And our numerator is still 1 plus cos x. The denominator, we can drag it out front and make it the denominator of its own fraction. 1 over sine squared becomes cosecant squared by reciprocal identities, and we just have our 1 plus cos x. And we're going to do a little demonstration of this technique in the next example. Again, we are rationalizing the denominator. So the left side is just a couple terms added. Over here on the right, we do have our denominator, our fraction. So we're going to do cos of x over 1 minus sine x. And the clue was to rationalize. So we're going to multiply the top and the bottom by the conjugate of the denominator, 1 plus sine x. The only difference is the sign change. If we do it to the denominator, we must do it to the numerator. So in the numerator, let's even distribute right now. Cos x times 1 is cos x. And then we're going to have cos x times sine x is going to be sine x times cos x. Plus sine x cos x. Let's see what happened to our denominator. Well, we could FOIL it out, and our middle terms will cancel. And we should always just remember that it's going to be the first terms multiplied. 1 times 1 is 1. It's always minus. Sine squared times, or sine times sine is sine squared of x. Okay. What else can we replace there? Well, that denominator is 2 terms, but we can make it a single term with a Pythagorean identity. Sine squared plus cosine squared equals 1. Subtract sine squared from each side. Cosine squared is the same as 1 minus sine squared. So I'm going to replace my denominator with cosine squared of x. And the numerator stays the same. Now if we notice, every term in the numerator has a cos x. Our denominator has cos x. So we can do some simplification. Or we can look at it, let's pull it apart into 2 fractions first. That might be easier to see what's going on. So our numerator is 2 terms with a plus in between it. Our first term is cos of x. Its denominator is cos squared of x. We have plus, and then our second term is sine times cosine. And the denominator is still cos squared of x. So what cancels? Well, this numerator gets wiped out by one of these, so now it's cos to the first in the denominator, and a 1 is left up top, so we have 1 over cos. Plus, this cosine will take out one of the 2 in the bottom, so we're going to have sine over cosine. Sine over cosine. Ooh, sine over cosine. That should be starting to send off some signals. Sine over cosine is the same thing as, you know, if you're at this point and you're starting to get a little stuck, you know, look back to the original problem. We're working on the right side. What do we want in our final side? Okay, secant plus tangent. Is either of these the same thing as secant? Yeah, cosine and secant are reciprocals. So 1 over cos is secant x, plus sine over cosine is tan x. There we go. We turn the right side into the left side. We've verified the identity. In example 6, back to the guidelines in the previous video, it says usually pick one side, work with the one side, and get it to match the other. You know, sometimes it's easier to work with one side until you get it simplified down pretty nice, and then say, okay, I'm going to hop over to the other side and start working on that one and see if I can get them to match. And that's what we're going to do on this one. So actually, let me slide this over a little bit. I'll put a nice divider line right down the middle. And we're going to work on each side independently. So when I look at that left side, let's see what we have here. Cotan squared and 1 plus cosecant. Well, I could think about a Pythagorean identity here, but we don't have a squared in it at all. But what could I replace cotan squared with? Well, if you go to your formula sheet and maybe manipulate that around a little bit, you'll see cotan squared is the same thing as cosecant squared minus 1. And that's over 1 plus cosecant theta. Cosecant squared minus 1. Can we factor that? You know, think of x squared minus 1. When we factored x squared minus 1, we had x plus 1 times x minus 1. So we can factor that numerator into two terms. Cosecant plus 1 and cosecant minus 1. And our denominator is 1 plus cosecant theta. Aha, look at that. Our denominator, 1 plus cosecant, is the same thing as cosecant plus 1. You know, when we're adding, it doesn't matter what order we add in, so these are going to cancel. And we're left with cosecant of theta minus 1. You know, what we started with was pretty complicated. We had two different trig functions. One of them was squared. You know, we worked on it and got it down to something a little more concise. One trig function minus 1. That's a lot easier than what we started with, but it doesn't look like what we have over here on the right. So let's play around with what we have on the right and see if we can get it to match. There is nothing squared, so we're not going to use any trig or Pythagorean identities. We got a single term denominator and two terms in the numerator, so let's bust it up. Our numerator is 1 minus sine theta. We can break it into two separate fractions, and each of them have the same denominator, sine theta. So let's see here. 1 over sine, well, sine is reciprocal with cosecant theta, just like we have here, minus anything divided by itself is 1. That was a little easier. Cosecant theta minus 1, cosecant theta minus 1. We worked with both sides sort of simultaneously until we got them to be the same thing. So let's see what we have next. A couple problems for practice in the huddle. So let's see here, when I solved these, and again, there's more than one way to solve almost all of these problems. I took the left side and I worked with the left side to get it to match up with the right side. We do have a minus in there. There are two terms on the left and we are multiplying two things on the right. That's a single term. So we are going to need a Pythagorean identity for sure. So I'd use some reciprocal identities on there maybe. Maybe turn them into fractions, get a common denominator. 25 is a little tricky. In number 19, I would do sort of like we did in the last one. Right down the middle, you know, work on the left side, simplify it down until you get maybe something minus something, and then work on the right-hand side until you work it down to that same solution. So these are a little tricky. Again, you know, a lot of trial and error, a lot of flipping back to your formula sheet. Stick with it. You know, pause the video, try those, come back, and check your work. So here in the first one, number 25, let's see, what did I do? We got two terms that we're subtracting. And let's see, here's the sine, and cosecant is the reciprocal of sine, so I'm going to change that cosecant to a 1 over sine x. And then we're going to have minus sine x over 1. Now what? Well, if we're subtracting or adding fractions, we need a common denominator. So I'm going to multiply the denominators that I do have. 1 times sine x is sine x. See, if I multiply up this way, my denominator sine x, I already have it, so I'm going to multiply my numerator just by 1. 1 times 1 is 1. And then minus, over here, I had to multiply to get sine x as the denominator. I'm going to multiply the numerator by the same thing. Sine times sine is sine squared. Now again, to go from two terms to one term, we are going to need a Pythagorean identity, and we've just created a scenario where that is going to work. So 1 minus sine squared is the same as cos squared. Cos squared of x over sine x. Now remember, sine over cosine is tangent, and the flip of it, cos over sine, is cotan. But we have a cosine squared. Well, that doesn't matter. You know, we can just pull this apart into two fractions that are multiplied. To get cos squared, it would be cosine times cosine. And our denominator is sine x, or you could think about it as 1 times the sine of x. So 1 times the sine of x. Well, our final answer here is cosine times cotangent. So we do need a cosine. This 1 over cosine will stay as is. Cosine over sine is cotan. And that's exactly where we wanted to get to. And the hint I gave on number 19 was to work both sides simultaneously. So it doesn't matter if we start on the left or right, we just want to make it more simple than what we see right now. So let's see, where do we start here? Cotan. Cotan. Can we do a Pythagorean? We could do a Pythagorean on that. But when I see tans and cotans, I like to turn them into sines and cosines. So this numerator, cotan, is going to be cos squared over sine squared. And that's divided by this cosecant. Well, we can turn cosecant into a form of sine or cosine. Cosecant is 1 over sine. So we have a fraction divided by a fraction. To do that, we bring up the denominator, invert, and multiply. So this is going to turn into a multiply problem. This is 1 over sine t. So that becomes sine t over 1. So we can see on the diagonal we're going to have some cancellation. This sine wipes out one of these from the sine squared. So let's see now. We're left with, if we multiply straight across, cos squared of t divided by sine of t. It's not exactly getting close to what we have over here, but we can work a little bit more. Pythagorean identity. Cosine squared is 1 minus sine squared of t over sine t. Getting a little better. It's looking somewhere. Oh, do we actually have it? Yeah. 1 minus sine squared of t over sine t. I guess we didn't even have to work both sides on that one. We already have it. Okay, I think when I worked this problem earlier, I might have started with the right side and broke it into two separate fractions. 1 over the denominator sine t minus the second term sine squared t over sine t. So on the right here, this sine squared would be reduced down to a sine to first by dividing out this one. So what we have is 1 over sine t, or cosecant of t, minus sine t. So that's where I stopped on the right side. Cosecant t minus sine t, that's pretty simplified. We're going to keep working this left side, and you'll see that those will match up. So again, on these problems, there are usually several ways to get the right answer. Some might be longer than others, some might have some wrong turns, but you can usually work them out. So when we got down to here, again, we're going to break it apart just like we did on the right. 1 over sine t minus sine squared over sine t, and we get the exact same thing. Cosecant of t minus sine t. So they do match up. And that's the end of 7.2. Okay, the assignment for this section is on page 555.